Hey, what's up, guys? Welcome to Box Plots Day 2. In this lesson, we're going to start by reviewing what we learned in Lesson 1 in the 5-point summary, and then we're going to go deeper. We're going to look at what is some information that we can gain from looking at a box plot. So let's dive in. In our box plot, we have 5 points. That is why sometimes it's called the 5-point summary. Okay, and so in our box plot, we have the smallest value in our box plot is called the minimum. Another name for minimum is the lower extreme. Okay, so the smallest value is, again, the minimum or the lower extreme. The opposite of that is the largest, right? On the other end, we have our largest, and that is the maximum. And that is the upper extreme. Okay. And then, right, in the middle of our box plot, we know that is the median. Okay, that is the median. Now, so once we have our median, that divides our data into two sides. We have the lower half, then we have the upper half, all right? And so the median, or the middle number on the lower half, that's called the lower quartile, LQ for short. Another way you can, another name that we use to refer to the lower quartile is Q1, okay? And then on the other side, the median for the upper half is the upper quartile, UQ for short. And another way that you might hear that referred to is Q3. All right, so this is what we learned last time. These are the 5 points of our box plot. Again, minimum, lower quartile, median, upper quartile, and then maximum. All right, now quartiles. All right, when you hear quartile, what word do you may you think of? Right, maybe you think of quarter. Right, and if you think of quarter, that will be really helpful. Right, how many quarters does it take to make $1? Well, 4. Right, so quart often refers to as 4, all right? So quartile is the 4 sections that make up the box plot, okay? So each box plot has 4 sections. There's this one section, 1, 2, 3, 4. Those are my 4 sections. And if you think about it, right, how much is a quarter worth? Well, it's worth 25 cents. Well, each quartile represents 25% of the data. 25% of the data. Okay, so that is quartile. Next term I want to define for you is the term range. The term range. The range is the distance from the minimum to the maximum. So it is how far. Okay, how far from the minimum to the maximum. In just a moment, I'll show you how to calculate that. I just want to define these for you first. And then secondly, we have the interquartile range. Well, we're still talking about range being a distance, but this time we're looking at the distance from the quartiles. So it is the range or the distance between the lower quartile and the upper. From the lower and upper quartiles. Or again, really, it's the length of the box. How long is the box? All right. So these are some terms that we are going to be looking at and figuring out from our box plot. All right. So let's look at how to calculate the range. How do we calculate the range? Well, again, we said the range is the distance from the minimum to the maximum. So I'm looking at how far it is from this minimum to this maximum. Well, to calculate that, what I have to do is I have to take the largest number and then subtract that by the smallest number. Or in other words, I am taking the max and I'm subtracting the min, right? The minimum, okay? And so when I do that, that is going to give me the range, or how far, or the distance, okay? So the largest the maximum here is 78. That's my maximum. So 78. The minimum, or the smallest, is 56. This is my minimum. Again, and then I'm going to subtract those. Even though I have 54, that's a smaller number. Again, my minimum is where that dot is. So that's why it's 56 instead of 54. And then when I subtract that, that is going to give me my range. So 78 minus 56, that is 22. Okay, so that is my range. Next, let's look at how to calculate the interquartile range. Well, to figure that out, we have to take the upper quartile and we're going to subtract the lower quartile. So we're taking the upper quartile minus the lower quartile. Or you could think about it, you may also see it Q3 minus Q1, all right? So again, the upper quartile minus the lower quartile, okay? So what is the upper quartile? Well, what's the value there? That is 74. So I'm going to do 74 minus the lower quartile, which is 60. So to find the interquartile range, or how far this box is, how long the box is, I'm doing 74 minus 60, and that will give me 14. And that is how I find the interquartile range. All right. So next, I want you to pause the video, and I want you to try to answer the next two questions on your own, right? It's just, we just did it. This is how you calculate it. So I want you to try to apply what you just learned to this next example, all right? So pause it, and then I want you to come back and see if you did it correctly. All right, so it says the box plot represents the test scores from the multiplication facts test in Mr. Redmond's class. All right, so here are the test scores. What is the range? Okay, well, to get the range, we are taking the largest number minus the smallest number. So the largest number on my box plot, the max, is 100. So we're going to do 100 minus the minimum, which is 30. Oh, sorry. Let's do minus the minimum. And 100 minus 30 is 70. All right, so 70 is the range. That's the distance from the minimum to the maximum. The interquartile range, again, I'm going to do the upper quartile minus the lower quartile. All right, so the upper quartile is 90. The lower quartile is 50. And the interquartile range, when I subtract that, is 40. All right. So hopefully you got that right. If you have any questions, feel free to raise your hand and ask. But that is how you do the range in the interquartile range. All right. Now, lastly, we got one more thing. I talked to you about how each section of the box plot is 25%, right? Because there's 4 sections. And each section is 25%, okay? So here's what I want you to understand. Each piece is 25%. It doesn't matter how long it looks. Each section, each part of the box plot is 25%. It could be a smaller piece or it can look longer, but each from one dot to the next is 25% of the data, okay? So what percentage of the test scores are less than 50? Okay, so if I look at 50, and again, I want you to imagine I'm just looking at 50 here, and I want to see how much of the data is less than that. Well, that's only one section of the box plot, so what's less than that would be the 25%. Okay. The next question says, what percent of the test scores is more than 90? Okay. Well, then I go to 90. Again, I'm looking at 90 here. How much of the box plot is more than 90, is above the 90? Well, if I'm looking at that, then that's just 25%. Now let's look at the next one. What percent of the test scores is more than 50%? Okay, so I got to go to 50. I'm looking at 50 here. Now I'm saying, how much of my box plot is above 50? Well, it's 3 sections, 25, 50, 75. So it is 7. Again, imagine I got 3/4. I would have 75 cents. And then lastly, what percent of the test scores is more than 60? More than 60. Hopefully you're seeing this by now. If I go to 60, okay, how much of the box plot is to the right of 60? And that is 1, 2, and so that is 50%. And so in this lesson, we've learned how to find the range, how to find the interquartile range, and then also how to determine what is the percentage of the data in each section of the box plot and answer some questions. And so we're going to continue this. We're going to practice using a Desmos activity. So I want you to apply what you learned in that next activity. And let me know if you have any questions. Hope this has helped you. And I look forward to day 3.